Good afternoon, guys. I'm in here going ahead and I'm going to record this video just to remind you of what we did in class. I have a list here of the subsets of real numbers because, who remembers Q? I never remember Q and I. I don't remember which one is which, or I and Z. Those are the ones that I can't remember. I'm as human as the next guy. We're going to listen to Mr. Barkley for a second, and I'm going to write down that this guy right here, real numbers, don't forget, are R. Maybe I'll write it in something darker on top. R. How's that? Is that better? Yeah, we can see it now. All right, so real numbers are R, and it says it here on this one. I pulled this out of the book. And then we start going outside to in with one set sitting on the outside, and that's our irrationals. They're not really a part of that. The way everything tunnels in. All right, so we have rational numbers. Those are any numbers that can be expressed as a fraction. See, there's a fraction here. Fraction here. This can be expressed as a fraction. This can be expressed as a fraction. And think about it. If you set it out loud, 125 1,000ths, there you go. That's a fraction. Then we have our irrational numbers. That's the guy over here. That's our square root of 2. That's pi. Other things I talked about today. Any square root that isn't a perfect square is irrational. So now we have integers. That's z. That's right here. We get in a little bit closer, right? Because it doesn't encompass all those fractions and decimals. Now we start getting to positive and negative whole numbers. Okay? And then we move into our whole numbers. Okay, and I'm not going to tell you what the letters are for it. You see it right here. I'm actually going to leave this little box up here up for the next piece that we do. Now we have whole numbers, starts with 0, includes 0, and goes up in order 1, 2, 3, 4, all the way infinitely. And then last but not least, natural numbers, which is very, very, very close to whole numbers. The only difference is no 0. Starts with 1, goes up infinitely. So I'm going to move on from here. I'm going to get rid of this. But I'm going to leave this up here. I'm actually going to put this guy up. I think it's this. No, it's this one. That's good. And this is good. And there we go. There it is. Now we're going to do our set builder notation. I'm going to remind you of set builder notation. I'm going to try and make it as easy as possible. And a friend of mine next door told me, hey, give him some steps, give him some ideas of how to do it the same way every time. And I did say, if I'm not mistaken, that you do write the same things every time. But if I list it, maybe it will be even better. So let me grab a bright color here. And I'll say the first thing you do in set builder notation, number 1, is a brace. Right? Add a brace. And then we go to number 2. The next thing you're going to write, this is number 2. Right? Now you're just going to write x. And what it means is the set of x's, that's what it says. Read the set of all x, and then that vertical line, such that, the set of all x, such that. So this is the set of all x, such that. That's number 2. Let's do it this way. Cool? Okay, so such that. And then number 3 is copy the inequality symbol. Copy. Just copy the inequality that you've been given. we start, it says, describe x is greater than 18 using set builder notation and interval notation. But right now we're doing set builder. So 3, just copy the inequality. So x is greater than 18. Sorry about that greater than symbol. It's not very good, but you understand what I mean. And don't forget the comma. I think the fourth part is the part that you don't like at all. So you look at the inequality and you decide, am I looking at a set of real numbers? Am I looking at integers? Am I looking at whole numbers? Am I looking at natural numbers? What am I looking at? Well, x is an element of. That's the next thing you put in. And that's it. And step 5, of course, you're going to close the brace. There we go. So using this idea, I'm just going to go ahead and write this. I'm looking at x is greater than 18. So step 1, put in that original brace. Step 2, give me set of x's such that. Step 3, put in my inequality. X is greater than 18, comma. Step 4, tell me what these numbers are an element of. Is this uber specific, or are we talking about all the possible values greater than 18? And the truth of the matter is, yes, we're talking about anything possible that's greater than 18. So I'm going to say, if it includes everything, that it's an element of real numbers. Cool? You don't have to do the double shadow there for R. Right? Sometimes I do that. And then, of course, step 5, close it up and you're done. So that's just going through the example. I'm going to do a couple more. I'm going to do them a little bit faster when I get to them. But I also want to talk about the next piece, which is interval notation. Now remember, in interval notation, I use a dark color here, parentheses. Remember, parentheses was like the open circle, non-inclusive. It just means it doesn't include that value. It doesn't have the equal sign, right? So we're going to use parentheses on that side, whatever side that value is on. And we're going to use, let's try a different color. We're going to, ooh, sorry about that. Woo! We're going to use a bracket if the inequality is inclusive. It's like the closed circle when you graph an inequality on a number line. So we say it's inclusive. And that's how we did it today. So I'm trying to make it, pretty much like what we talked about in class. That way I don't give you any new terminology that might freak you out. So we're looking at x is greater than 18. So starting from the left, right, we're looking at everything to the right of 18. So I'm going to write 18 is where we start. And then this set goes up infinitely. Now, does this inequality symbol include an equal sign? So do we include the actual value of 18? And the answer to that is no. So we're going to put parentheses around it. And remember, That's the, I had you star it, right? Remember, negative infinity and positive infinity get parentheses. Oh my gosh, that was horrible. Get parentheses only. Parentheses only. Okay? Excellent. All right, so we've gone through these examples again. Now what I'm going to do is get rid of this, go here. Now let's do a couple of examples. And I'm going to write on here, let's use a darker color so we can get to it. Remember, this is just x is greater than negative 8 and 8/10. So we're starting at negative 8 and 8/10 and going up. And remember, step 1 of set builder notation, put that first brace in. Step 2, the set of x's such that. Step 3, copy the inequality you've been given, negative 8 and 8/10. Forgot my comma. Step 4, now let's talk about what we're looking at. Are there any other specific? Do we have nothing but like a list of decimals? See how we have a list down here? A list of integers down here? Hint, hint, that's where we're headed. There's no list here, so we're talking about everything, every possible value greater than negative 8 and 8/10. So, just like before, this is a set of reals. Okay, that's horrible. Just write an R there, Sokol, you goofball. But that's it, right? So, brace x, all x's such that x is, copy your inequality, x is greater than negative 8 and 8/10, comma, where x, all the x's are elements of real numbers. Good? Great. Let me change colors, and we'll do the, it's not enough of a change. Let me change to this color. Let me change to the interval notation. And so we start at negative 8 and 8/10, and I'm just going to make it negative 8 and 8/10, comma, and it goes on infinitely, everything greater. So we're going to go infinitely, and it's very hard to draw with this thing. We know, because I told you just a second ago, we can never put brackets around infinity. So we know that we have parentheses there. Is there an equal sign here? Is it greater than and equal to? No. So it's not inclusive. Therefore, we're going to put parentheses around this one. Let's move on. We have a compound inequality. We actually have 2 in a row. But just like before, we're going to do the same exact thing. We're going to start with a brace. We're then, I don't like that color at all, I'm sorry. We're going to start with a brace. That's better. We're then going to put in the set of all x such that 5, just copy. 5 is less than x, which is less than 15, comma, and do we have a list of numbers? Do we have 5, 6, 7, 8, or 5, 5 and a half, 5 and 3/4, etc., etc., etc.? No, we just have everything between 5 and 15. So, again, just like before, it's an element of real numbers. Close it. Sound good? All right. Talking about interval notation. Now, interval notation is kind of fun here because we look at both of these, right? It starts at 5 and ends at 15, right? We don't have infinity this time. But do either of these inequality symbols have an equal sign? No, they do not. So again, we're just going to use parentheses around both ends. This is kind of fun. I don't know if you like it, but this compound inequality here, we're just going to keep using that or. All right, watch what happens. It starts the same way. Step 1. Step 2. Step 3, copy everything verbatim. Even the or. X is greater than equal to 1. Comma. Do we have a list of numbers like these guys? Do we have a list of counting numbers like these guys? No, we do not. I got to stop yelling. So again, just like before, we're still talking about real numbers. And we're going to close it up. Beautiful. Let's talk about interval notation. This is the fun one. We're actually going to have an or in between. We're going to have two sets of intervals, right? We're starting from the far left, right? It goes to the left infinitely. So we start with negative infinity. And we end with negative 11. We do not have an equal sign, so we're going to put parentheses here. And we have to put parentheses around the negative infinity. Now we have another set, right, that starts at 1 and goes upward, is greater than 1, and it goes on infinitely. That's not bad. Could be worse. Again, can't put a bracket around infinity, but guess what? There's an equal sign here. There's an equal sign here. So we finally get to bracket the sucker. It's our first bracket of the day. Beautiful. And last but certainly not least, now we have to make up our own inequality, right? So what do we have here? We have negative counting numbers or negative whole numbers going down and including negative 7, right? So we have x, I'm going to say x, let's use a different color. I'm going to say x is less than and equal to negative 7, all right? And then we'll talk about what those x's are, in, what subset these x's are an element of after we create our set builder notation. So we start just like we always do. Brace x such that use the inequality we just created. X is less than or equal to negative 7, where x is an element of, so these are integers. These are negative whole numbers. And integers are positive, negative whole numbers. So I'm going to make it z. I'll make it just fat. Fat and bright. There we go. And then I'm going to close with the brace. Now, super simple. We have everything to the left, or everything negative, and we end with negative 7. So we have negative infinity all the way up to negative 7. Sorry, I didn't change colors, but we'll survive it. Never a bracket. Never a bracket around infinity. Sorry about that parentheses. It was horrible. But what do we have here? An equal sign. So it includes, our set does include negative 7, right? It's right there. So I'm going to bracket negative 7. And that's it for that part of it. All right. Now we're going to move on to the second section of what we did today. And so I'll get rid of this. Actually, I think I can get rid of this. The next part is super duper easy. The only other thing that you're going to be required to do tonight is look at a function. This is a function, right? If a function of x, this says if a function of x is 5x squared, sorry, let me get there, is 5x squared minus 4x minus 6, find f of 3. And all that says is wherever you see an x, put a 3 in. Sound good? All right, well, let's do it. So we'll rewrite it as f of 3 is equal to 5 times 3 squared minus 4 times 3 minus 6. Okay? Sounds pretty good to me. All right. So we're going to square the 3 because that's our order of operations. Square the 3. We have 5 times 3 squared, which is 9, minus 4 times 3 minus 6. Okay, 9 times, and then we're going to go left to right with our multiplication. So 5 times 9 is 45, minus 4 times 3, which is 12, minus 6. Right? Yay! Cool. So 45 minus 12, what is that? 33. 33 minus 6, and 33 minus 6 is 27. That's all it is. Cool. Oh, look at how they're trying to trick you here. No numerical value whatsoever to put in. You know how super simple this one is. If it says find h of t, all you do is wherever you see an x, put a t there. So h of t is equal to 9 times t to the 9th. Oh, the 9th. Ding dong. The 9th. I'll rewrite that better. You'll see it. And it's minus 4 times t to the 4th. And it's not a very bright color, so I'm going to rewrite it in a different color. Plus 3 times t minus 2. Now I'll rewrite it in a color you can actually see. So h of t is equal to 9t to the 9th minus 4t to the 4th plus 3t minus 2. And that's it. You're done. You're done. That's all there is to it. Let's see what else I got. The very last thing is what I've got. Let me get rid of the last one. And the last one is probably the most annoying. Is it annoying? You say it's annoying. I say it's not. I say it's not annoying because all you have to do is read. Right? You have parameters. This is called a piecewise function. You're given parameters. If the value they've asked you to input is less than 3, then you use this first function, which is square root of 2x. If the value they're asking you to input or evaluate the function as is 3 to 8, then you're going to use this second function here. Right? And last, but certainly not least, this is a cool one because it's just you get an output. You don't even have to evaluate this function. So let's find f of 3. Oh, let's use a better color than that. I couldn't even see that one. Let's try this guy. So let's find f of 3. Now, we're going to use, are we going to use this first function? Is the number we've been given, is 3 less than 3? No, it is not. Is 3 either 3 or up to 8? Yes, it is the number 3. So I'm going to use the second function. And I'm going to evaluate 2 times 3. I'm going to put 3 in for x. And then add 10. Okay, well, let's evaluate it. 2 times 3 is 6, plus 10, which is equal to 16. Okay, well, we know how to do it that way. Let's go ahead and take a look at 8 and 5/10, or 8.5. What is f of 8 and 5/10? Which function are we going to use? It's not less than 3. It's not 3 up to 8. It is greater than 8. So the value that I put down, this is the function itself. It's just the number 42. And that's it, guys. So when I post your homework, you're going to be good to go. All right, thank you for your time, and I'm sorry the video is so long. Take care. Let me know if you have any questions.